this is our video lesson on division of complex numbers. We've talked about the other three operations with complex numbers, adding, subtracting, and multiplying, and we've even talked about raising I to different powers, but we have not talked about division, because division is actually a little trickier, as you might imagine. So I kind of want to start off with the concept of division as being the opposite of multiplication. So for example, if I asked you to multiply 3 times 5, well, that's 15. And if I were to ask you to create a division fact that's associated with this multiplication problem, well, you could create two division facts. You could say 15 divided by 3 would be 5. Or you could even say that 15 divided by 5 would be 3. Hopefully, no brainers there. It's a little different with complex numbers in the sense that division facts, it's not exactly the same process of dividing, but the concept, there's an analogous concept that if I know a multiplication answer, that from that answer I can get some division answers. So for example, if we multiplied 2 plus 3i times 5 minus 2i, I would get, well, let's see, what would I get here? I would get 10 minus 4i plus 15i minus 6i squared. And we learned that this can be simplified. So this is 10 plus minus 4i and plus 15i is plus 11i. And minus 6i squared is minus 6 times negative 1. I squared is negative 1. And we get 10 plus 11i plus 6, which is 16 plus 11i. So I know that 2 plus 3i times 5 minus 2i is 16 plus 11i. And we can create a division fact that is associated with this multiplication problem. In fact, we can create two. I'd actually have you stop the video here and see if you can create a division fact that would be associated with this multiplication problem, similarly to the way that we did in number 1. Hopefully you did pause the video. I really can't check that you did, but two division facts we can come up with. We can come up with, well, 16 plus 11i, that's the answer. That's like our 15 from before. And if I divided that by, say, 5 minus 2i, one of the original multipliers or factors, well, then I should get the other factor. I should get 2 plus 3i. Another division fact we could say is we could still start with 16 plus 11i and divide that by 2 plus 3i, and we should get the other factor, 5 minus 2i. Now, what's interesting to note here is it would be very difficult to look at this, 16 plus 11i divided by 2 plus 3i, and determine that it's automatically 5 minus 2i. So for example, you couldn't do something like 16 divided by 2, well, that's certainly not 5, or 11 divided by 3, that's certainly not 2. So the question is, how do we actually do this division problem without knowing the answer ahead of time? So that's our question number 3, is how do we do this division problem, 16 plus 11i divided by 2 plus 3i, without knowing the answer ahead of time? Of course, we know the answer ahead of time, so we can check. And the answer lies in multiplying by a conjugate. So just as a side note here, if I have 2/3 plus, say, 4/9, and I want to add these two fractions, I would be permitted to multiply this fraction 2/3 by 3 in the top and 3 in the bottom and get an equivalent fraction 6/9. 2/3 and 6/9 are equivalent fractions. So what we're going to do is we're going to multiply the green fraction top and bottom by the same quantity. And the quantity that makes sense here is the conjugate of the denominator. The conjugate would be 2 minus 3i. You might recall that when we multiply by conjugates, we actually get a real number answer. So what's going to happen is 2 plus 3i times 2 minus 3i is going to give us a real number answer. So let's do this multiplication out. So we get 16 times 2, which is 32. 16 times negative 3i, which is negative 48i. 11 times 2, 11i times 2, which is positive 22i. And positive 11i minus 3i is negative 33i squared. That might seem to be a mess, but this is all going to clean up very nicely. Divided by 2 times 2 is 4. 2 times negative 3i is negative 6i. positive 3i times 2 is positive 6i, and 3i times negative 3i is negative 9i squared. And now we need to simplify all of this, so we just have to be careful when we do it. On the top, I'm going to get, well, I have negative 48i plus 22i, which turns out to be negative 26i. Then I have 32 minus 33i squared. But remember that 33i squared is really 33 times negative 1, that this I squared is really a negative 1. And so what ends up happening here is I really add 33. And so 32 plus 33 is 65. On the bottom, we get some very nice things happening. We get a cancellation of positive and negative 6i. And I squared again becomes negative 1. So when I'm subtracting 9 times negative 1, I'm really adding 9. This is really an addition of 9 here. And 9 plus 4 is 13. So that cleans up very nice. Now, I have 65 minus 26i over 13. And I can handle this a few ways. One way I can handle it is to divide each of these guys by 13, which is, I call that sharing the love. You can see my little heart here. So 65, this really becomes 65 over 13 minus 26i over 13. And 65 over 13 is 5. And 26i divided by 13 is 2i. And here's our answer from before. If we remember, we saw this as a multiplication problem before, that when I took 16 plus 11i and divided by 2 plus 3i, we got 5 minus 2i. But here, the benefit of this, or the idea of this, is that I didn't need to know the answer ahead of time. If we multiply by conjugates, we can actually simplify and get the answer. And that's basically the gist of this. So I'm going to do a few more problems with you just so you get the idea, and then you're going to be on your own here. So write a quotient of 4 over 1 minus I in simplest a plus bi form. Well, again, it's necessary to multiply top and bottom of the original fraction by the conjugate of the bottom, which is 1 plus I. And this will get us a much easier answer to deal with. So we have 4 times 1 is just 4 on the top, plus 4 times I, which is 4I, divided by 1 times 1 is 1. Now here's a little thing I'm going to skip. When you have multiplied by conjugates, the middle two terms, the 1 times I, so the 1 times I is I, and the negative I times 1 is negative I, those are going to cancel. So I'm automatically going to skip them. Not because I'm not multiplying them, but because I know what the answer is going to be. And then I have 1 minus I squared. So now I have 4 plus 4I over 1 minus, and I squared again is negative 1. So this is going to become 4 plus 4I over 2. And again, we can divide 4 divided by 2 plus 4I divided by 2. And I get 2 plus 2I. If I wanted to just check this for a second, I could take this answer, 2 plus 2I, and multiply it by 1 minus I, and I should get 4. So let's see if I get 4. 2 times 1 is 2, yep. 2 minus I is negative 2I. 2I plus 1 times 1 is positive 2I. And 2I times negative I is negative I squared. This should be 4. The i's cancel. I get 2 minus, whoops, this should have been a 2i squared. 2 minus 2 times negative 1. Does that equal 4? Well, let's see. Negative 2 times negative 1 is a positive 2. And indeed, 2 plus 2 is 4. And here we are. We actually worked. So 2 plus 2i is the answer, and I just did the check on the side. One more problem to go over. We want to find the multiplicative inverse of negative 6. Well, I hope this is a familiar problem. Multiplicative inverses are basically the idea that, well, so for example, if I was solving an equation, if I was solving negative 6x equals 18, say. Now, typically, we would divide by negative 6. This would reveal x's value right off the bat. And these guys are inverse operations, multiplying by negative 6 and dividing by negative 6. So we know that. I just want to look at this a little bit differently. If I have negative 6x equals 18, I could multiply by 1 over negative 6. So I could take negative 6, which is really negative 6 over 1, and multiply by 1 over negative 6. These are called reciprocals, I hope we know. When I interchange the numerator and denominator of two fractions, these are called reciprocals, which are also known as multiplicative inverses, because these two guys undo each other. Multiplication by negative 6 and multiplication by 1 divided by negative 6 undo each other. So the multiplicative inverse of negative 6, the multiplicative inverse, is 1 over negative 6, which we simplify to negative 1/6. Same sort of a concept when we want to find the multiplicative inverse of a complex number. The multiplicative inverse of a complex number is its reciprocal. So I want to take the reciprocal of 1 plus I, which is 1 plus I over 1. That's 1 over 1 plus I. And then I want to multiply top and bottom to get this to see what real number this really is. I want to multiply by 1 minus I. That's the conjugate of the denominator. So 1 times 1 minus I is 1 minus I. And 1 plus I times 1 minus I, again, I'm going to use my shortcut in multiplying the conjugates. 1 times 1 is 1. I'm skipping the middle terms because I know they cancel. And positive I times negative I is negative I squared. And so this becomes 1 minus I over 1 minus negative 1. And this is 1 minus I over 2. I'm fine if you leave that as the answer. But if we wanted it in a plus bi form, we would want to technically do 1 divided by 2. So we'd share the love here. 1 over 2 minus 1i over 2. So you get 1/2 minus 1/2 I as your multiplicative inverse. Just as a check to that, so I'm kind of checking number 6 here. If we had 1 plus I, and I multiply that by its multiplicative inverse, which is 1/2 minus 1/2 I. Well, 1 times 1/2 is 1/2. 1 times negative 1/2 I is negative 1/2 I. I times 1/2 is positive 1/2 I. And I times negative 1/2 I is negative 1/2 I squared. So the 1/2 I and the negative 1/2 I cancel. I get 1/2 minus 1/2 times I squared, which is negative 1. And we get 1/2 plus 1/2, which is 1. Which is exactly what we wanted to get, because think about this. When I take negative 6 and multiply it by its reciprocal, which is negative 1/6, or its multiplicative inverse, we would get negative 6 over negative 6. Oh, sorry, I should say positive 6 over positive 6. Negative 6 times negative 1 is positive 6. 1 times 6 is 6, and I get 1. This is exactly what we should get when we multiply multiplicative inverses. So thanks for watching. The homework is to do the rest of the problems on the back, as many as you can. I will post the answer key, or I'll text it to you guys, and you'll be able to check. We'll have a little bit of time on Monday to work through any questions that you had.